Okay, what I have is my Python file here where I'm playing around with random seed generation. So before I do the final work, I'm just learning Python. And what I did was I'm plotting a bunch of data to files. Okay, so random, not a bunch of data. I'm doing like 10 iterations of random number for each of these constants. So I'm just sticking in, allowing for like a 10%, 20% variation. Yeah. So I'm allowing for plus and minus 10% variation. And anyways, so with that, I stick it in files. So I didn't want to go on all this, but so I'm using Python to make 10 separate files that has some random data in it that lets the constants vary by plus or minus 10%. So then I plot them, so that means there's 10 of them here. So they all start out, they randomly vary. And I'm just doing like 10 steps or something and 10 variations. So anyways, they all start at the same value, and then they vary by a random percentage each step. So it's boom, random percentage, random. It's always a plus and minus 10% around the mean. And I do it with each one. So the electron is 1.602 times 10 to the minus 19th. The mass of the electron is 0.9 something times 10 to the minus 30th kilograms. Alpha, the fine structure constant, is 0.007 whatever here. And anyways, all these things are, I can eventually have a different color for each case, each run. So in the future, when I run my seed cases, it'll be the opposite of this. Like, what my purpose here is to generate different seed values based upon the NIST codata. So I'll have different values, and I use those as my initial conditions for the waveforms, the algorithm, the sign flip algorithm. So I put these different variables in, or constants in, let it run, and it should converge to the same point. And that's why I'm just doing all this plotting ahead of time. Here's the speed of light, and again, it's just random stuff right now. I'm just learning the code. So I have 3 times 10 to the 8th, 10 different cases here. It looks like 10, yeah. And it's my own generated data.